Hi and welcome to Eric's Bench. Today here really an old Yaesu FRG-7700, which is receiver only, and the SWL told me that he has some problems with receive, so he told me it does not seems to match really. So that means most likely we have a frequency error somehow, and yeah, that is what we want to investigate. Yeah, and as you can see, our receiver is set to the 80 meter band on 3.6 megahertz, and it is set to lower sideband. I mean, it is a little bit difficult because this old receiver only shows as last digit 1 kilohertz, so we do not have a clear indication of you know, the right frequencies down, let me say minimum into the 10 hertz. So that means this is not really very accurate, but anyways, if we see that I have the receiver set to 3.6 megahertz and do a control check on my communication tester, then you can see that on SSB with 3.6 megahertz we should get feedback from the radio with 1 kilohertz, because I'm feeding in 1 kilohertz as audio frequency. Let me go a little closer. So that is what I feed in, and I expect the radio to play back 1 kilohertz, because when I transmit with 1 kilohertz tone on 3.6 megahertz, of course what I need to hear in my receiver is a 1 kilohertz tone, but I don't. So you see, what I really receive is 2.39, so that is almost 2.4 kilohertz, and that is far off from what it should be. It should be 1 kilohertz, so we should read here 1 kilohertz. And now let me change here the main dial on our receiver until we see here 1 kilohertz. So let me do that simply, and you already see that it is going down, and you see that our audio sign is changing, which is right. And now you see I am going down to let me try to get it. So the main dial here on this receiver is very touchy. It is far away from what a ham radio is like. So you see, it really takes a while until I can really adjust it, and oh my goodness, so that is really touchy, unbelievable. But anyways, what we can see now, we are 34 hertz off, and you already see that our signet improved very much. And now when I go back here to the radio, you see that my frequency counter here is telling me, hey, we are on 3.598 megahertz, and that means here we have an offset of 2 kilohertz, right? So that is really 2 kilohertz, and I mean, it is not completely matching. I mean, what do you expect with only 3 digit, where the last digit is telling us the 1 kilohertz steps, right? but we have seen on our counter on our test set that we was at almost 2.4 kilohertz, which means our meter was telling us we are 1.4 kilohertz off, and well, we are seeing here 2 kilohertz, and you know, what do you expect? So that can't display it any more accurate. So that is what it is if you only have 3 digits. And yes, of course, our SWL is right, so he has a problem with his receiver. So when he is looking into the cluster, he is never able to dial the frequency to what is told in the cluster, because then he has always a mismatch. And yeah, so that is most likely due to the age of the radio. It is misaligned. So that is what I would say from the first glance. And that means it is an old radio. That always means that you really have a lot of steps to do to check the alignment. But let's try. Because he's really loving his old receiver, and therefore let's crack it open and let's test some test points, and we will see how far our radio is really off. Okay, and here's our top side of the radio, and you really see that is really old school technique. So everything is through hole, of course. So back in the days when these radios were produced, there was almost no SMD technique. Maybe in some really professional electronics, but not here in consumer electronics. So that is more or less a cheap production. Anyway, so let's go through our test points and let's see what we can find. And I mean, it is always the same. So I have a video online where I show an entire alignment process. There you get a feeling how long it could take to do a fully alignment. Anyways, we follow, of course, now the instructions here in the service manual, and you see we start with the counter clock frequency, because this radio really has a frequency counter inside. And that is how it was. So we have here our counter module, and we have here our crystal for our counter, and that was completely different to what we see today. Today we do not test our frequency which is generated in the radio. So we are using the PLL, and you know, the processor is calculating the frequency which should be on the given main dial setting, right? So it is never a complete readout in modern equipment. It is always the PLL and the processor, maybe the main processor or the display processor, who is calculating the frequency, and this frequency is then displayed on the display. In older radios we really have a frequency counter, which is really counting the frequency, and that is a huge difference between an old radio and a new radio, right? and therefore, of course, we need to check if the counter is good aligned, because that could be already a problem if the counter is misaligned. I mean, I do not really believe that the counter is misaligned in our example here, because we have seen that, you know, the frequency really is approximately 1.4, 1.5 kilohertz off, and that is what our display is telling us. So most likely our counter is not that far away, but anyways, we go through, and if necessary, of course, we improve it. Okay, and so I put here my counter to the test point 07, and down there you see the little trim cap where, if necessary, we have to align our frequency. And now let's see what our counter is telling us. Okay, and what we can read here is 3.2768 megahertz, and that, as I said already, is our counter alignment. And you may believe it or not, but that is really spot on. I really do not touch it. There you have it, test point 1007, 3.2768, and that is really spot on. So great. So now we go ahead. So I do not show you now every line here in our maintenance and alignment manual. I jump to the test point, we read the frequency on our counter, and then we see if we have to align it or not, because that will speed it up a little bit. Alright, so this is the SSB carrier frequency adjustment at test point 1005, and you see that we are reading 456.7 kilohertz, and we should read 456.5 kilohertz. So yeah, that is almost nothing, 200 hertz, but well, let's try to improve it a little bit. Okay, so that is fine now, 456.5, very good, no problems. And yeah, the pots are less touchy as I thought, so that was really great. So let's go ahead to our LSB. I switch here to LSB, and you see our frequency is changing to 453.5, and yeah, we should see 453.5. we see 150 hertz off, so that is really not much. So let's see if this pot is as good as our upper sideband pot. So let's see, it looks pretty nice. It is not too touchy, and you see 453.5. So up to now it was not so far off, so all is fine up to now. Okay, so next step is our PLL reference oscillator, which is of course a very, very important alignment, and we should read 3.5 here at the required 3.2 megahertz at the required test point. So let me see, and wow, spot on. That is really spot on. And the oscillator itself is 6.4, which is at test point 04, which is here. So that is absolutely spot on. So that is really, really good, because you know, the normal crystals we very often see are far away from being accurate. And you see, this crystal here is absolutely spot on. And that is very seldom that we can see something like this. Okay, and what we see here is our Pll Local Alignment, which should read exactly 47.6. And okay, so we are off a little bit. So what is it? It is not so much. 20 kilohertz. What is it? 15 kilohertz. 1.5 kilohertz approximately. Yeah. So let's try to align this exactly to 47.6. Okay, and down here we have our crystal for our 47.6 megahertz, and right beneath our crystal we have our little trim cap down there, and we are definitely not able to align to 47.6, so we are approximately, as we have seen it, I don't know, 1.5, 1.7 kilohertz off, and it looks like that we really have here a problem with our, so that is basically our second local oscillator. And it looks like that our second local oscillator is doing some garbage here. So once again, setting here our radio to 3.6, right? And again, setting our let me see. No, sorry. Sorry for the horrible camera work, but I just wanted to show it all together, but you see that is not easy. Anyways, with our misaligned second local oscillator, we see that we have here on 3.6 an audio feedback of 2.8, and yeah, that is telling us that really the second local oscillator is doing some trouble, but to be sure that it is really our second oscillator, I adjust here my and again you can't see it, I adjust here my generator to 47.6, right? And that frequency we want now to inject into our radio. So I pull off here my output from the second oscillator, and you see we are losing our signal, which is right. And now I'm using simply our second oscillator from my generator, and let's see what that is doing. And here it is, and you see, of course, we have still, but that is maybe here a little bit, the alignment at our front panel. As we know, it is really touchy, and you see with our external second oscillator frequency, it is really working fine. And I just want to show you my display. So it is still on 3.6, as you can see, and there I'm feeding in here our second oscillator frequency, which comes of course from my generator over there. And no focus, sorry for that. But anyways, horrible camera work once again, sorry for that, but no tricks here. So that is really what it is. It is a problem with our second oscillator, and therefore we really have to see how we can improve it here a little bit. Okay, so that means we really need to focus on our second oscillator circuit, and maybe that we have a problem here with our trim cap, which is possible of course, or with our parallel cup, which as it is called, it is in parallel to our trim cap, or maybe our crystal itself. So everything can be. And the first what I would try is to swap out the pot, and then maybe that is already fine. So let me do that first, and then we can discuss it any further. Okay, so board is out, and it is right here. So now we take care on our oscillator, second oscillator, and as I said, let me swap out here our little trimmer, and let's see if it helps. Alright, and I have the board back in the radio, and what you can see down there, we have a new pot for our second local oscillator, right? And I also replaced the old trim capacity here in our first local oscillator. So both do have new trim caps, and now what we can do is we can check our frequency. And you know, our second oscillator was off, and we have seen that with our frequency generator, injecting the right frequency made the unit work. Okay, so when I now go here to the test point of our second oscillator, which is here. Yeah, let me see. The problem is I cannot really, that is a problem, I cannot leave it in here. Maybe that way. Now we can go over to our meter, and what you see is that we really exactly on frequency, so 47.6 megahertz. So that is really awesome. Yeah, that finally means that all oscillators are set to the right frequency, and now we should see if now we are back on the wanted frequency. Well, and you see, whoa, we are really at the edge here to the next digit. So let's see if we put it now on 14100. So I'm on the 20 meter band right now. And let's go over to our tester and let's see what you can't see it. I have to change it here a little bit, and now there it is. So here we have our feedback frequency, so that is exactly now on 1 kilohertz, and we see here, yeah, it is really at the edge, and that is I can't align it any better, as it is still an old radio, right? But it is now, yeah, let me say it is 90%, okay? So sensitivity is really good. I've tested it. It is better than what we have in our specs, and now all the oscillators are just fine, and we really have it working now. But you see, it is really at the edge. Anyways, that doesn't bother us, because we need to take into consideration, yeah, it is still an old radio, and we really can't move it, make it new. Well, the only thing what could be done, and that is what I would recommend to the owner, is to really swap all capacitors, electrolytic capacitors. So we all know that is always a problem. So I will recommend it, but yeah, we will see how the owner reacts on that proposal. But anyways, from the other than that, we can say our radio is back working, and so we really can stop here our video. Thanks for watching, and catch you next time.